Okay, so we have learned how to launch objects horizontally. The next part is we're going to learn how to launch objects at an angle and see how far they can go. So in order to do that, we need to do a little bit of a trig review. So let's say that we have a triangle. And we've got a 90-degree angle down here. All right, so just identify some sides. So we know that this is known as the hypotenuse. This would be the opposite side, and then this would be the adjacent side. And this right here would be some angle. Now in this class we're going to denote that with a symbol known as theta. So anytime that you see this sign, that means that it's theta. It's known as theta, but we're talking about some angle. Now, I'm sure you've all heard the saying SOHCAHTOA. This is an easy way to remember some trig properties. So if you want to know the sine of theta, then you know that it is opposite over hypotenuse. And then let's say you want to know the cosine of that theta, of that angle. Then you know that it's ca, so it is adjacent over hypotenuse. All right. So really, sine theta and cosine theta are simply ratios between side lengths. So let's go ahead and look at a scenario where we are launching something at an angle. Alright. So let's say we've got our ground, and then let's just say we're going to launch something from a cannon. Right, so when we launch something from a cannon, you can kind of see that I've got it at some angle. So when the cannonball is fired, it's going to come straight out this way, and it's going to have some initial velocity. Right. And it's going to take a parabolic path and kind of do something like this. Alright. So, as you can kind of see, with our cannon, we actually form a right triangle. So if we just go right there, and make a 90-degree angle here. Alright, so we launched at some angle. Alright, so we can look at S versus X, look at the range. So we call this SX. And there's one more important thing before I jump into the angles here. So if we look at, one thing that's very important is SY. Now if we're looking at this, what would you call SY? What would be the displacement in the Y direction? Well, we start at the same level and we end at the same level. So we can call SY, displacement in the Y direction, 0.